Hello everyone, I am Mustafa Eren Gökçemen. I am a mechanical engineering student in Bilkent University. Today I will present you my Physics 102 final report presentation. First, let's look to theory of my experiment. Capacitors has a resistance in AC circuits which is called capacitive reactance, and this is unlike normal resistors. This is changing with respect to frequency. More frequency means lower capacitive reactance because capacitors in higher frequencies, capacitors charge and discharge faster, and this allows to more current flow through the circuit. So this means lower resistance. Secondly, I want to introduce you my setup. The blue thing in the left is a AC capacitor, and also there is a resistor on the right of it. These are connected in series, and there is a multimeter and a AC power supply. Now I want to introduce you how I collect my data. First, I adjust my AC power supply to 900 Hz. Then I measure the voltage across the AC capacitor with a multimeter, and then I record the data. After that, I measure the voltage across the resistor, and again I read the data from the multimeter. After that, I adjust my AC power supply to 1000 Hz, and I repeat the process as you see. This is my data table. You just watch the 9th and 10th experiment, but I repeat this process 10 times to reduce error and see the correlation. After I finished data collection procedure, I just draw a capacitive reactance versus inverse frequency graph to demonstrate the correlation between the capacitive reactance and frequency. Finally, I calculated the slope of the basefit line, and then 1 over 2 pi times the slope gives me the capacitance, experimental capacitance, and then I check my error according to this data, and I found my error as 3.7%. This error might be happened due to manufacturing errors of multimeter, AC power supply, resistor, or the capacitor. In conclusion, the experiment successfully demonstrated the inverse relationship between frequency and capacitive reactance. Based on the slope of the graph, the experimental capacitance was calculated as 96.3 nanofarad, which is very close to the theoretical value of 100 nanofarad. The low error of 3.7% proves that the measurements were accurate and the theoretical formula works perfectly in a real circuit.